You're staring down the Cambridge Physics 0625 exam. The clock's ticking, palms are sweating, and you just flip the page to a massive 8-mark question on energy resources and Sankey diagrams. Now, you might know the physics perfectly, but do you know exactly how the examiner actually awards the marks? Today, we're completely stripping away the fluff and exposing our precise strategy to secure top band scores in this heavily penalized section.
Look at this classic two-student duel describing a coal power station. One simply writes, coal makes electricity and loses heat. The other writes, chemical energy in coal transfers to electrical energy, thermal energy is dissipated. Now, I want you to spot the exact invisible error that drops that first answer down multiple grade bands. It's not just that it sounds, less sophisticated. It literally misses the required energy transfer terminology that the mark scheme legally requires to give you points.
Okay, let's dive right into this. Section 4, Forces and Energy, is exactly where these crucial marks are hiding. This isn't just about casually knowing what a wind turbine looks like, right? It's about totally mastering Section 4.2 on energy transfers and 4.7 on energy resources. The specific part of the syllabus is the exact battleground where your final grade is decided, simply because it combines conceptual physics with, well, really precise data representation. Let's look at why ordinary revision and rote memorization completely fail in the exam room for this topic. It's because of these exact technicalities pulled straight from the source notes. We're talking missing units, rounding way too early, vague explanations, and graph axis errors. Listen, you can memorize the entire textbook, absolutely every page, but if you forget the unit for joules or mess up the scale on your graph axis for a Sankey diagram, the examiner is going to strictly dock your points, no question. But actually, all of those are just minor technicalities compared to the ultimate grade killer. Consider this a major jump scare warning. Conclusions not supported by data. Think about it. If a question gives you a data table of energy efficiencies, and you write this beautiful, grammatically perfect conclusion based purely on your own opinion without referencing the actual numbers right there in front of you, you score 0 for that section. Literally 0. So, what does this all mean? Well, it brings us to the million-dollar question. What is the hidden examiner clue that instantly flips a vague, low-scoring answer into a top band score? What's the secret ingredient they are actively scanning for when grading your paper? In just a moment, I'm going to reveal that exact clue, and trust me, it will completely change how you approach this entire exam. But to actually use that clue effectively, you've got to learn the structural blueprint of a perfect answer first. You can't just sprinkle a magic clue onto a super weak foundation, right? You need a framework that essentially forces your brain to process information and write exactly the way the Cambridge mark scheme wants to read it. So here is your elite 4-step examiner framework. Step 1, concept. You explicitly state the underlying physics principle. Step 2, evidence and data. You pull the exact numbers from the prompt. Step 3, scientific reasoning. You connect that data directly back to the concept. And step 4, examiner wording. If you process every single explain or describe question through these 4 exact steps on test day, your answers are going to be virtually bulletproof. Let's quickly define this crucial final step because examiner wording is absolutely non-negotiable. It means using exact Cambridge terminology. It means substituting values with their correct units directly into your text. And honestly, most importantly, it means completely fulfilling the command word. If the question asks you to compare, you don't just list facts independently, right? You have to actively weigh them against each other using specific comparative language. And this brilliantly illustrates the evidence and data step in action. When you're comparing resource efficiencies, like coal at 33%, wind at 45%, and hydro at 90%, you don't just write, hydro is very efficient. No way. You write, hydroelectric power, with an efficiency of 90%, transfers significantly more useful energy per unit of input compared to coal's 33%. See the difference? You absolutely must use the data as your evidence.
Now let's see how this builds with a mathematical proxy for a Sankey diagram. Take a look at the energy transfers happening in a power station. We've got 33% useful electrical energy output and a massive 67% wasted thermal energy dissipated to the surroundings. In a Cambridge Sankey diagram, these percentages translate directly into the physical width of the arrows. The input arrow splits, and the widths must mathematically represent those exact proportions. It's like a giant puzzle that has to fit perfectly.
Okay, let's gamify this explainer for a second with a quick pause and predict. Time for a high-stakes interactive challenge. If you're drawing that Sankey diagram on your exam and your arrow width for the 67% wasted thermal energy doesn't perfectly match the exact percentage scaling data, what's the penalty? Do you think they give you the benefit of the doubt if it just looks, relatively close? Think about your answer for a second. Well, here's the harsh reality, straight from the source. The examiner's verdict: marks denied for inaccurate scale and missing units on wasted energy arrows. The mark scheme is strictly mathematical, folks. If your chosen scale is 1 millimeter equals 1%, and your 67% wasted energy arrow is drawn 50 millimeters wide instead of exactly 67, you lose the mark. It is a precise mathematical model, not just a loose sketch. Let's escalate the stakes even further with some harder data analysis. Here, we're comparing output versus wasted energy for coal versus wind. This isn't just about drawing arrows to scale anymore. This is about deep evaluation. When the exam throws a complex comparison like this at you, you've got to look way beyond the basic efficiency percentage and analyze the total megawatt output capacity versus the total waste. Let's bring back our two-student duel to see how this actually plays out. The first student writes, "Wind is better because it's green." 0 marks. It's vague, it's colloquial, and it uses absolutely zero data. The second student writes, "Wind provides a renewable kinetic energy to electrical transfer, but the data shows a lower overall megawatt output than coal." This is flawless. They perfectly executed the scientific reasoning step of our framework, merging core physics concepts with direct graph analysis. So, the crucial point we've been building to. Here is the hidden clue, finally revealed. The secret ingredient the examiner is actively hunting for in your answer is exact scaling and substituted values with units. That is the magic that flips a vague answer into a top-band score. They don't want a generic story. They want to see that you physically extracted the 450 megawatts from the data and wrote it down with a capital M and a capital W. Let's lock this knowledge in for good. Before you turn the page on any energy resource or Sankey diagram question, run through this rapid-fire final exam survival check in your head. 1. Are there substituted values with units in your text? 2. Are your significant figures correct? 3. Is your graph scale perfectly accurate? And 4. Is your final answer reasonable? Because if you calculate that a power station is 150% efficient, you really need to catch that impossible error before the examiner does. To really solidify this newly learned strategy, let's read this rule directly from the source material. A strong answer includes correct terminology, substituted values with units, and command word fulfillment. Guys, this isn't just good advice, this is the literal rubric for success. Write this down, memorize it, and let it guide absolutely every sentence you construct in Section 4. But we still have a massive unresolved problem here. You now have the ultimate framework. You know to use data, you know exactly how to perfectly scale a Sankey diagram. But if you misunderstand the command words at the very start of the prompt, you still stand to lose 50% of your marks. Think about it. If you describe when you were actually supposed to explain, your beautiful data means nothing. Your exam survival is literally still at risk. You simply cannot afford to let a misunderstood verb ruin your perfectly structured physics answer. You need to know exactly what the examiner demands when they use specific command words. So, up next, we'll decode the Physics 0625 command words that decide the mark band. Subscribe to our YouTube channel, Ace the Exams at acetheexams_IGCS to excel in your Cambridge examinations. See you in the next Explainer.